Hello everybody and welcome to 11.2 on movement. In this unit we're going to be looking at the structure of muscles and bones and how they kind of all link together to allow us to move. Okay, so the first thing to remember is that we have bones. Other organisms have exoskeletons, but basically both of them facilitate or allow movement to occur. Okay, and the way they do this is by providing an anchorage for our muscles. So the muscles in our skeletons are obviously outside of the bones, and in exoskeletons the muscles are inside. Okay, so they're kind of the opposite way around, depending on what type of organism you are. We have the way the three things work together. So our bones and our muscles, we have a lever, which is usually in the form of a bone. We have a force, which is usually supplied by a muscle, and we have a fulcrum, which is usually in the form of a joint, which is the point at which two bones kind of join together. So what are the different kinds of levers and joints that we can have? So the first one here, you can see a first class lever. In this one, you can see you've got the fulcrum here, which is at the base of where the skull meets the spine. Okay, so it's kind of active. The fulcrum is in the middle. Okay, you've got the effort force, which is given by E, which is provided by this muscle here. And you've got the resultant force, okay, which is basically the force that causes the chin to move upwards. Okay, so obviously you've got this muscle here, which is acting on this fulcrum here. Okay, as it contracts, okay, it pulls the head down, and the resultant force is that the chin tilts upwards. Okay, so that's kind of explains these three, E, F, and R. In a second class lever, okay, an example of this is here. You've got the fulcrum look in the toes. Okay, right in the toes here. The resultant force, the effort force is provided by this muscle here in the leg, okay, the quad, okay, and the resultant force is that the heel of your foot is lifted off the ground. So the fulcrum is in the toes, the joint in the toes. The effort force is supplied by this muscle here, and the resultant is that your foot moves off the ground. And this third class lever here, look, this is the bending of the elbow. You have the fulcrum in the joint right here in the elbow. The effort force is supplied by the bicep, which is this muscle that's on top over here, and we have the resultant force, okay, which is here in this direction here. Okay, something important to remember is that generally in skeletal muscles, so muscles that attach to our skeletons, they generally occur in pairs that are what is known as antagonistic. Okay, this means that when one contracts, the other one relaxes. Antagonistic muscles produce opposite movements at a joint. For example, in the elbow, the tricep extends the forearm while the biceps flex the forearm. Okay, so you can see here when the bicep is contracted, okay, the tricep is relaxed and the arm is bent. When the bicep is relaxed and the tricep is contracted, okay, the arm is straightened. Insects have an interesting set of muscles, very similar to the way, of course, that ours kind of work. Same thing, same antagonistic idea. So it has three pairs of appendages. The hind limb is specialized for jumping. Okay, so this is the hind limb, the one at the back. You can see it here. Okay, and you can see that there's three main kind of parts to it. You've got the tarsus, the tibia, and the femur, which is the long bit up here. Okay, and again you can see that represented on here. The tibia here, this would be the tarsus, and the femur is this bone up here. Now basically what happens is when the grasshopper is preparing to jump, the flexor muscles, which is this one here, contracts and brings the tibia in, okay, close to the femur. okay, forming almost like a Z. So a Z in the way that this is one leg, here's another, here's another. And the femur and tibia are brought closer together, okay, that's called flexing. When the extensor muscle relaxes during this phase, the extensor muscles will then contract, extending the tibia and produce a powerful propelling force. Okay, so when we get the opposite of that occurring, here's our extensor muscle right here. Okay, this is going to contract. Okay, this part is going to relax. So these two are antagonistic, same here. Okay, and this is going to extend, producing that really, really strong force. Okay. All right, some very key points about joints and motion. Okay, we need to learn these and what the different parts do. So what you can see here, this is a typical synovial joint. Okay, you can see there is parts of it which are made of bone. All right, so this is the humerus bone. So this is the arm coming down from the shoulder. Okay, and this is the ulna and radius, which are the parts that go towards the hand. You've got biceps on top, the triceps underneath. You've got a joint capsule. You've got synovial fluid, and you've got layers of cartilage as well. So what does each part do in this? So the points where the bones meet are called the joint. So that's here. This is the joint area right here. And this is what allows what we call articulation. So it allows one to move inside of the other. Now, because of this movement, of course, can be friction. And so the body has a way of dealing with this friction. And one is to provide it or layer it with something called cartilage. You can see cartilage. Cartilage is something that is on the outside of the bone. It kind of layers the bone, and it's a tough, smooth tissue. Okay, that covers the bone, and it prevents the contact between regions of the bone that might rub together. Okay, and so it's there to prevent friction. Okay, it's also great for absorbing shocks, okay, that could cause the bones to fracture, because we all know we have cartilage in our trachea. Okay, and whenever we push that, okay, it's flexible. All right, so it prevents fracturing. Okay, between the layers of cartilage, we have synovial fluid. It fills the cavity in the joint, and it lubricates the joint, and so helps to prevent friction again in the joint. The joint capsule itself, which is this area here, it's made of tough ligament, which covers the joint, and it seals the joint and holds in the synovial fluid and helps prevent dislocation. Okay, so this is made of ligament. And it's kind of holding all this in place. All right. Okay, anything else there we need to talk about? No, I don't think there is. So it's important to remember that different joints allow different ranges of movement. Okay, so the structure of a joint, including the joint capsule and the ligaments, determines the movements that we have that are possible. The knee joint can act as a hinge, which allows only two movements. Flexion, which is bending, and we have extension, which is straightening. Okay, so you can see that here. Like you can see, this is the extension where the knee is being bent long ways, and we have flexion where we're bending the knee. It can also act as a pivot joint. Okay, the knee has a greater range of movement when it's flexed than when it is extended. So we also have our hip joint between the pelvis and the femur, and it's a ball and socket joint. It has a greater range of movement when the knee joint in that it can flex, extend, and rotate, and move sideways and back. And that latter type of movement is called abduction and adduction. Okay? I think then, guys, for this first video, we're going to stop there, and the next video we'll look at structure of muscle fibers. Thank you.